Good morning, ladies and gentlemen. This is Mr. Rowe. We're looking in geometry, part A. This is lesson 9, and we're looking at how to prove that triangles are congruent, and we're going to use a two-column proof. So how do we prove that triangles are congruent? In the lesson, we had some theorems and postulates that you were given with some examples that show you how to prove that two triangles are congruent. First one is side, side, side. That's kind of most simple, basic postulate. That's just basically showing that all the sides of one triangle are congruent to the same sides of another. And we have side angle side, which says that if we have two sides and the included angle of one triangle, they have to be congruent to the same two sides and the included angle of another. And we have angle side angle, basically the reverse of the previous one, two angles, and then the side in between those angles congruent to the same two angles inside of another. And then finally, angle, angle, side. So that's two angles and then a side not between those angles congruent to the same two angles inside of another. So if we recall a two-column proof, two-column proofs is what we've been looking at so far most of the course. And we have a column for statements and a column for reasons. Each statement has a reason. The reason is a justification. This is basically like, you're a lawyer, you're defending your statement with a reason. So each one of these will have a statement with a reason to go with it to justify it. The reasons can be things like definitions. It could be given. It could be a postulate. It could be a property. Anything that we can use to show that something is congruent or that is a logical statement. Let's take a look at our first example. So here is our triangle, and we've got two triangles here that we're trying to prove are congruent. It looks like probably this triangle and this triangle. Let's see what we're given. We're told that BD bisects AC. That gives me a piece of information. I can already see something that I can use with that. AB is congruent to CB, and then I have to prove that the two triangles are congruent. ABD is congruent to CBD. So now I like to plan out what I'm going to say and do before I do it. So I do that by marking up the picture and thinking about things I can use. So what I know right here, because BD bisects AC, is I know that this side right here is congruent to this side. That's the definition of bisects. Bisects cut something in half. And so I know I've got a statement of reason right there. I'm told that AB is congruent to CB. So that is another side that I already know is congruent. Without doing a whole lot of extra work, what else do I see? Well, right here, I see that this segment BD is something that's in both of these triangles. So it's a member of both triangles. So we looked at some properties earlier in the year, and earlier in the course, actually, and one of those was called the reflexive property. The reflexive property says that a segment is congruent to itself. So just by marking up and thinking about what I'm going to do, I've got my proof right here. I've got side, side, side. Looks like what I'm going to use. I've got three sides congruent to three sides. Let's take a look at my statements and reasons. So my first statement, BD bisects AC. Why is that true? Well, that's the given piece of information I know. Based on that given piece of information, I want to make a statement about these two sides. So I know that AD equals CD. How do I know that? That's the definition of a segment bisector. Well, based on the fact that those segment lengths are the same, I also know that the segments are congruent. And why do I know that? Because that's a definition that we talked about, the definition of congruent segments. Congruent segments have the same length. Well, here's my next statement. Well, this is another piece of information that we were given at the beginning, that AB is congruent to CB. So that's given. And then my final statement, which we talked about, was that BD is congruent to itself, and that's the reflexive property of congruence. So now I have my three sides right here congruent to each other. So based on that, I can now state that the triangles are congruent. And what's my reason? Side, side, side. You don't have to write out side, side, side postulate. You can just put SSS. That's a standard abbreviation. Let's take a look at our next example. So here is our two triangles. Let's see what we're given here. We're told that point C is the midpoint of AE and BD. So this right here is a midpoint of both of these segments. So let's see what else we're getting. Nothing. But we're just going to have to use that and figure out something to prove that triangle ACB, so this triangle ACB right here, is congruent to ECD. So those two triangles are congruent. So again, let's mark up what we can figure out just from the given information. Because C is a midpoint, I know that this segment is congruent to this segment. And since it bisects the other segment as well, I already know that this angle, or this side right here, is congruent to this side. So I've got two sides already. I'm not given any other information, so what else can I use? Well, this is a set of intersecting lines. So earlier in the course, we talked about what happens when we have lines that intersect. We end up with something called vertical angles. And these vertical angles right here are going to be congruent to each other. So I'm going to use that rule right there to let me know that those two angles are congruent. And I'm going to use that to make my proof. So it looks like I have a side, angle, side relationship. So that's how I'm going to build my proof using side, angle, side. So here are my statements and reasons. Point C is a midpoint. Well, how do I know that? I was told. I was given a piece of information. Based on that, I know that AC equals EC. Well, how do I know that? That's the definition of a midpoint. A midpoint separates two segments into two equal parts. Well, based on that, I know that those segments are congruent because if the two segments have the same length, then they are congruent. And that's the definition of congruent segments. I'm going to make the same two statements for BC and DC. Or BC and DC. So I've got definition of midpoint again, because the midpoint will separate those into two equal parts. BC is going to be congruent to CD for the same reason that it was before, definition of congruent segments. So now I have my two segments. I need my angle. Well, I'm going to state that angle ACB is congruent to segment ECD because of what we talked about. Vertical angles are congruent. That's something we talked about earlier in the year. And then finally, I have my sides and my angle. So I have side, angle, side right there. So triangle ACB is congruent to triangle ECD because of side, angle, side. So that's how these proofs are put together. So plan it out first and write your statements based on your plan. So here's our next example. So what are we given here? We're told that PQ, so PQ right here, is parallel to TS. And we're told that PQ is congruent to TS. So just some information about PQ and TS so far. And that's all we're given. So we have to prove the triangle PQR. So PQR is congruent to triangle STR. So this triangle, and the order does make a difference because of the angles. So we're basically going to prove that these two things are congruent. So let's take a look at what we have to do here. So based on the given, I'm going to use this given first. I know that this is congruent to this. So I know that because it's given right there. I know that PQ is parallel to TS. So I'm going to mark a parallel symbol right here. So I know that these two sides are parallel. It's a terrible parallel sign. Let's try to draw with this. It's difficult. Let's see if I can get it. That's good. So those are parallel. So based on parallel, I'm going to use some things that we talked about in our lesson on parallel lines with transversals. These are transversals. These basically would intersect two lines. So based on that, I will know that this angle right here is congruent to this angle. This angle is congruent to this angle because of alternate interior angles. These are interior angles. They're across the transversal from each other, so they're congruent. I also know that this angle right here is congruent to this angle for the same reason. Alternate interior angles are congruent. So it looks like I have enough information for angle, side, angle. So that's going to be how I'm going to build this proof, is with angle, side, angle. Let's take a look at the statements and reasons. PQ parallel to TS. That's given. Based on the fact that those two lines are parallel, I can state that PQR, which was that first angle I marked right here, PQR, is congruent to STR by alternate interior angle theorem. I can also state that the other angle, QPR, so QPR is congruent to TSR. And this order does matter, so make sure you write these out correctly. The order does matter with the angles. And the same reason, alternate interior angles. Now I have my two angles. I need to have my side that's in between them. So while that was given, PQ is congruent to TS. And so now I have enough for angle, side, angle. And so I have triangle PQR, and it's important that these match up. P has to match up with S when you write it. So you can see right there, I've got P matched up with S. I need to have T matched up with Q, which I do. And then R has to be matched up with R. So I've got my things named correctly. And so now I can just say that it's side or angle, side, angle. So that's how you build these proofs. And let's take a look at our last example. I'm doing an example of each kind so you can see, or each postulate and theorem. So let's see what we're going to do here. We got angle A is congruent to angle E. E is congruent to A. That's given. I know that ABD, and these triangles overlap, so that's very important that you mark this up so you can see what you're talking about. And if you wanted to, you could actually redraw this separating them. So this angle right here, ABD, is congruent to the angle EDB, so this angle. And then let's see, we have to prove that triangle ABD is congruent to EDB. So let's mark this up and see what we've got here. So first thing we were told was that E is congruent to A. So I've got that marked right there. That's a given piece of information. I was also told that ABD, so that's ABD, which is this angle right here, is congruent to angle EDB. So EDB. So that's this angle. And so that's all I'm given. So what else do I know? Well, again, if I look at BD right here, we saw this in another proof. That segment is a member of both triangles. If you were to draw these out, I'll try it right here. So we have A, BD, and then we draw the other triangle. We've got E, so you see we've got BD, them both triangles. So that is reflexive property again. So there is my side that's congruent. So I've got angle, angle, side. So that's how I'm going to build my proof in this one. This is actually a very short proof. So we got A is congruent to E. Angle E is congruent to angle A. That's a given piece of information. We've got angle ABD, which we talked about here. ABD is congruent to EDB. And that's marked in our picture. That's a given piece of information. And then we had this side. BD is congruent to BD. Well, look, there's my angle, side, angle. So basically, this proof is done with one extra statement. And that's angle, side, angle, or angle, angle, side, excuse me. So remember, the idea here is to plan out your proof first, then write your plan. I like to kind of think of the statements I'm going to write with the reasons, make sure that each statement and reason follows. You can't make a statement in any of these problems until you have something that helps you justify it. So you can't, for example, if we look at one of the other examples, we couldn't say in some of the previous ones, let's go back to this one. Like I couldn't say alternate interior angles first before I said the given. So I had to say the given and then say that the reason for it. So make sure that you're doing that as you do these proofs. If you're having trouble with these and you still can't quite understand the concept of proofs, please let us know in a teacher message or make an appointment for a help session so we can help you out.